Give some very straightforward algebra advice, and starting with this system on the left here, I notice I have two linear equations and two variables, but I notice I also have fractions. Whenever you deal with fractions, this should be your first instinct is to eliminate, say, the denominators here. So we say 2, 8, and 8. What you do is to eliminate denominators, you multiply by the least common denominator on both sides. So I notice between 2 and 8, the least common denominator would be the least common multiple of these things. So I could write out the multiples of, say, 2, and I could write out the multiples of 8, 8, 16, 24, so on and so forth. I notice that 8 is the first one they have in common. We are going to take everything in this equation times 8, and what you start to see happening is that it eliminates the denominator. I would get 8 over 1 times 1 over 2, which is half of 8, which is basically 4. I would get 4x. 8 times 1/8 is going to be its reciprocal, is going to be 1. So I get minus 1 y, and then we say 8 times this over here, I get basically the 8's cancel out, I get left with negative 3. So if we were to solve this system now, I'd say, well, what method would I use now? I would definitely use elimination method. I notice that if I add these right now, as a matter of fact, I get on the left side I get 0, on the right side I get 0. So if I were to solve this system, I get infinitely many solutions, and it'd be really easy to go check this by graphing these because you would see that these two lines intersect at every point x, y. And so we would also say that this is a consistent system, and as well as consistent, it is consistent dependent because these two lines meet at every single point. They depend upon one another. In this last system here, you notice you have decimals. I'm just going to come out and say it. You can shift your decimals on the entire constraint or entire equation as long as you shift the decimal the same number of places on every single term, because what you're doing is you're multiplying or dividing by 10. So for instance, if I took every number in the top equation times 10 times 10, or took it times 100, I'm not going to show my work here. Really what we're doing though is this. We could just rewrite this as long as I do it in both equations the same number of spaces, 3x plus 4y equals 75, because all I did was go 1, 2, 1, 2, and 1, 2. So the second equation here would be 2x plus 6y, rightfully is 90. To solve this, I think I would do elimination method. So why don't we go ahead and carry this one out here. I'm going to eliminate my x's. I'll take the top equation times a negative 2 and the bottom equation times a positive 3. So our new system would be negative 6x minus 8y is equal to negative 150, whereas the bottom equation would be 6x plus 12y's would be equal to 270. And when I add these together on the right, it looks like I get 120 positives. X's cancel out. We get 6y, so y, solving for y on both sides, we get y equals 20. So now that I know that y is 20, we could go plug this back into one of the original equations. It looks like, if I'm looking, I'll guess I'll use the first equation here. Plus 4 times y, which is now blank, is 75. Well, I get 4 20s here. And we say, plus 80, 75. And so I get 3x equals negative 15, sorry, negative 5, when I subtract the 80. And I get x is negative 5/3. And I don't think I made any errors here. So it is okay to get fractions for an answer. As a matter of fact, this is why we solve things algebraically in the first place, so that we can get this first solution. So we say, so long as I've made no mistakes, this is our solution. We can go check this by graphing. We could have done this with elimination method. And this is a consistent system. It is consistent because we got an answer, and it is independent because these two lines did not produce infinitely many results. Cheers.